system of 3 equations and 3 unknowns. This is example 4 on 8.9.2. They've given us our 3 equations here. Okay. And what we're going to try to do is we're essentially going to try to turn roughly these guys almost into zeros. Okay? We want to get rid of the x in the first equation, then in the xy, so that we're left with just a z variable equal to some number so that we could solve for z, and then substitute back into equation 2 and 3 to solve for x and y. Okay? So, creating zeros. In order to create zeros, we're going to go back to our old method of substitution. We're going to start multiplying equations by some number, some scalar, some factor, whatever you like to call it. And we're going to add and subtract equations to get new equations. Okay? So, in the very first one, I'm going to talk about equations 2 and 3, and we're going to put them together. We're going to work with those two. Okay? Now, my goal here is to get rid of x in my first one. So, equation 1 is x minus y plus z equals technically 1. And equation 2 has 2x plus y minus z equals 11. I've left space because I'm going to do something to the first equation. Okay. We will then be creating a new equation. Okay. This new equation we can call equation 4 if we like. What we're going to do is we're going to multiply the first equation by a factor of 2. Okay. Or even, just so we're consistently adding tends to be a little easier, we can multiply it by negative 2 if we like. So if I multiply the first equation by negative 2, these terms are going to change. I'm now going to have negative 2x plus 2y minus 2z. And then our number 1 is going to be subtract 2. So now that I have that, I can add these two equations together. And what will happen is, think of this like negative 2 plus 2 gives us 0x. I've now created a 0 at the bottom. Now 0 times x is going to be 0, but I wrote it in there just so you know that there is technically a number created out of that. Then we get plus 3y minus 3z is equal to negative 1. Sorry? Oh, thank you. Thank you. That now becomes 9. I'm having trouble writing equations down properly. Okay. So we have that now. We've now created what could be technically called our third equation here. This is still a linear system, and it still works what we have. So we're going to call it equation number 3. Okay? And the easy way to write equation 3 is 3y minus 3z is equal to 9. That's our equation 3 here. That's an easy way to write it. So, sorry, not 3, 4. We already have an equation 3. We've numbered these. Equation 4. Okay, now what we're going to do is we're going to use what we have here, and we're going to add equation 4 and 3. We're going to work with equations 4 and 3 now. Okay? So equation 3 and equation 4. Now what we're going to do is, oh, I forgot to do it to the third one. My fault. We've done that to the second one. We've eliminated the x from equation 2, and it's now essentially equation 4. I want to do the same process with equation 3 and equation 1. Okay? So we did this with 1 and 2. And now I'm going to work with 1 and 3. So that eventually, sorry, we're going to have a new equation 5. And we'll be working with equations 4 and 5 together. Okay? So same idea as we did before. This time we're just going to jump right to it though. Because the third equation says 3x plus y plus 2z equals 12. Again, I want to get rid of the x. So I'm going to multiply equation 1 by negative 3. That will give me negative 3x plus 3y minus 3z is equal to negative 3. And now, same idea with elimination. We're going to add these together. to get a new equation. This is going to be our 0x plus 4y minus z is equal to 9. So equation 5, we'll now call this, is equal to 4y minus z equals 9. We've gotten rid of our x's out of our systems of equations. We now have 2 equations left. Same idea, I want to get rid of another variable. So we're going to focus on questions 4 and 5, and we're going to combine these two to get rid of another variable. So I'm going to multiply. Now we could do it by fractions, or we could do it by technically whole numbers. In the textbook, they multiply by fractions so that everything's kind of working with ones. And what they do here is they multiply the first equation, or equation 4, by a third, and then they multiply equation 5 by negative 4 over 3, and then they add the two together. We'll show you what those look like. When we multiply this by a third, this equation, okay? In other words, kind of like a factoring out of 3. That's going to give us y minus z equals 3. Another version of equation 4. They multiply equation 5 by negative 4 over 3. When you do that in here, that's going to give us... Why would they do that? Sorry, they don't multiply that one by 4 over 3. What they can do is you can multiply this one by negative a quarter. And the reason I would do that is so I can eliminate the two y's. Okay? So when I multiply this by negative a quarter, that's going to give me negative y. It is going to give me a fraction for z, but we can kind of get rid of that as we go along. Our fraction for z is going to be plus 1/4 z is equal to negative 9 over 4. Now in the book they tell you to use fractions when going through this and multiplying. Another way of doing this, if you guys remember elimination, is you can find a common multiple between the two numbers. 3 and 4. It would have been a lot easier had we multiplied, instead of multiplying by fractions, we multiplied by whole numbers and eliminated. Okay? And just to make this a little simpler, I just showed you what the book relatively did. We're going to multiply by whole numbers just so it's a lot nicer to look at as we go through this. Okay? We'll do some of the putting it in simpler form after. So we're going to multiply the first equation by the number 4, and we're going to multiply our second equation, or equation 5, by the number 3. That way our y value will be 12. Okay? In fact, we'll do it negative 3 so that we add. So 4 times that gives us 12, minus 12y is equal to 36. And our other one gives us negative 12y plus 3y is equal to negative 27. Okay. Same idea with elimination. We're going to subtract these two, and we're going to essentially create what is known as equation 6 in this. So we're working with a lot of different equations here. Oh, yeah, those are z's, not y's. So we go to add these two. This is going to give us our 0y. This will give us negative 9z. And this will give us 9? Yeah, 9. So in the end, we're going to figure out that our equation 6 is negative 9z is equal to 9. Or in other words, z is equal to negative 1. That is our equation 6. So we've used elimination to solve for z. We then substitute our z value back into equation 5 to solve for just y. Okay, so we have equation 5 here, 4y minus negative 1 is equal to 9. That's going to be plus 1, but when we move to the other side, it's going to become 10. So 4y equals, is that the right number? Yes, you're right. Becomes 8. Thank you. And then y is equal to 2. And now we have a y value and a z value.
Kevin Ganesh and Kevin Mascow, please come to the main office.
We can then plug it into any of the first 3 equations. We'll have a y value and a z value, and we solve for x. We'll plug it into the first one since x minus y plus z equals 1. X minus y plus z equals 1.
Can Kevin Ganesh and Kevin Moscow please come to the main office, please?
We'll take our x minus 2 minus 1 equals 1. X negative 3 equals 1. X equals 4.
And Kevin Ganesh and Kevin Moscow